Okay, in this video we'll be looking at solving linear inequalities. Now, an inequality is a statement like this one. It reads that 5 is greater than 2. And what we'd like to do is use the tools we have from solving equations for inequalities as well. So it's important to check that the same tools work, and the most basic and useful one is this idea of doing the same thing to both sides. Now we're going to track what's happening on the number line below. The fact that the blue 5 is greater than the green 2 is seen by the fact that the blue dot is to the right of the green dot, the same direction the inequality arrow points. And we're going to see if it stays that way when we do the same thing to both sides of this inequality. So first, let's try adding a number to both sides. So we're adding 2 here, and this just slides the dots across like this, which clearly keeps the order of them the same. The blue one is still to the right of the green one, so we're totally fine to add the same number to both sides of an inequality without messing it up. And if we change the plus to a minus, say minus 6, same deal. This time we just slide to the left, but once again the order hasn't changed. Blue is still to the right of green and everything is still fine, meaning we can add or subtract to both sides of an inequality without messing it up. So let's reset the picture to the 5 and the 2, and now think about multiplication, say by a number like 2. While the dots aren't sliding uniformly, you can still see that the blue is to the right of the green. 10 is still greater than 4. So it looks like it's still totally fine to multiply or divide both sides by a number like 2. Even though we won't show division here, it's all the same. But the moment you change the multiplication to a negative number, like multiplying both sides by negative 2, what's going to happen is these dots swing to the other side of 0 on the number line, still at 10 and 4, but now the negative versions. But what this rotation does is it causes the blue dot to now lie to the left of the green one. Negative 10 is less than negative 4, so we've switched the order around. And so that's not fine. That has messed with the inequality. The order of the resulting numbers has reversed. So what we can see in general is when we're trying to do the same thing to both sides of the inequality, almost everything is okay. Just watch out for any step where you're multiplying or dividing both sides by a negative number. And if you need to make such a move, you need to flip the inequality sign because the order of the numbers will reverse. 5 bigger than 2, but negative 10 less than negative 4, that sort of thing. And most of the time, apart from that one little subtlety, solving a linear inequality is just like solving a linear equation. So let's see a couple of examples. We'll start with 3x minus 1 being less than or equal to 20. I know at this level you're probably used to just moving things to the other side of the equation or inequality or whatever, but it's worth this time being fully explicit with what move we're making to both sides, because we've got to watch out for the sign possibly flipping. So our first move, like if it were an equation, would be to add 1 to both sides. Now we said before, adding or subtracting can be done without messing with things, so we just have 3x is less than or equal to 21. Our final move is to divide both sides by 3. But because we're dividing by a positive number, there's no need to worry about anything flipping, and we just get x is less than or equal to 7. And that's our answer. X is allowed to be any number that is 7 or lower than 7. And for our last one, we'll do 7 minus 2x is greater than 12. Again, our first move is just as if it were an equation. We could take away the 7 from both sides. But once again, subtracting a number from both sides will not mess with the inequality. So we just have negative 2x is greater than 5. But our final step would be to divide both sides by -2. This would give x by itself on the left and a -5/2 on the right. But because to get there we had to divide by a negative number, we need to switch the direction of the inequality so that now x is any number less than -5/2, not greater than anymore. So that's how you can solve linear inequalities, almost the exact same as equations. Just watch out for steps where you need to multiply or divide by a negative, and if you do, it messes with the order of the numbers, so the direction of your inequality has to switch around on those steps. That's all for this one. Thanks for watching. See you later.